Have you ever wondered how the smallest tool in your toolbox, the center punch, comes into existence? Or how seemingly complex objects such as a spur or helical gear are made? If so, stick around. We're about to dive deep into the fascinating world of engineering experiments. First up, let's talk about the making of a center punch using a mild steel round bar. Begin by heating the round bar in a furnace until it's red hot. Then shape the hot steel into a point using a forging hammer and anvil. Afterward, temper the pointed end by heating it until it turns a straw color, then quickly quench it in water. This process hardens the steel and gives the center punch its unique properties. In a nutshell, the creation of a center punch involves heating, shaping, and tempering a round bar of mild steel. Moving on to the second experiment, which involves the making of a mild steel cuboid with a slot inside it. Start by cutting a rectangular piece of mild steel to the desired dimensions. Then, using a milling cutter, create a slot in the center of the cuboid. Remember, the depth of the slot should be less than half the thickness of the cuboid. In essence, the making of a mild steel cuboid involves cutting, milling, and precision measurement. The third experiment is all about creating an external thread on a mild steel round bar. To begin, secure the round bar in a lathe machine. Then, using a threading tool, cut threads into the outer surface of the bar. This process requires precision and skill, as the spacing and depth of the threads must be consistent. The key takeaway from this experiment is the importance of precision and consistency in thread cutting. Next, let's discuss the making of spur and helical gears using a universal milling machine. Start by setting the gear blank in the machine. Then, using a hobbing cutter, shape the teeth of the gear. For a helical gear, the machine must also rotate the gear blank at a specific angle during the cutting process. The making of gears showcases the complex capabilities of milling machines and the precision required in gear manufacturing. Our fifth experiment explores various types of measurement techniques, including linear, angular, temperature, force, and torque. For linear measurement, a vernier caliper or micrometer is typically used. Angular measurements often involve the use of a protractor or angle gauge. Temperature measurements can be taken with thermocouples or infrared thermometers. Force and torque measurements, on the other hand, require specialized equipment such as force gauges and torque wrenches. This experiment emphasizes the importance of proper tool selection for accurate measurement. Lastly, we examine the limits of dimensional tolerance using various comparators. This experiment involves measuring a sample part with a comparator to determine if it falls within the specified tolerance limits. If the part's dimensions are within the tolerance limits, it passes inspection. If not, it fails. This experiment highlights the critical role of quality control in manufacturing. In summary, these experiments provide an insightful look into the world of engineering and manufacturing. From the creation of simple tools like a center punch to the complex process of gear making, these experiments showcase the precision, skill, and knowledge required in the field of engineering. Furthermore, they emphasize the importance of accurate measurement and quality control in ensuring the functionality and reliability of manufactured parts.